Okay, so the next lesson is related angles, signs of trig functions. Related angles is just when we are going to make reference to a certain vector. We have to come up with the related angle, and we've already done that when we've been adding vectors together. Remember, vectors is going to give you a magnitude in a certain direction. Those are the bare problems that you worked with last year. The ij going in from polar coordinate system. Polar coordinate system is a vector because it gives you magnitude or the length of a hypotenuse in a certain angle direction. From that, we had to create a right triangle in order to find the I and the j if you're going from polar into rectangular coordinate system. So if I give you a vector that was 12 at an angle measure of 135, what quadrant is that in? The second quadrant. Now, when we start talking about related angles, what angle do I, or how would you put that into rectangular coordinate system? Maybe I should ask that. Because we know that this is 12. We would draw this down, correct? And then we would find that angle measure, and then you would have to do inverse tangent. Well, first I got to find that angle measure. What's that angle measure? You wouldn't have to do inverse tangent. Sorry, that's not going to find you the angle measure. But we are going to be using sine cosine. That angle measure, you're going to take 180 minus 35, and you find out that this is a 45-degree angle. This is what that 45-degree angle is what is known as your related angle. It's the angle towards the x-axis. So then from there, we would do the sine of 45 is equal to y over 12. And we would also do the cosine of 45 is equal to adjacent over hypotenuse, or x over 12. So you take 12 times the cosine of 45 and 12 times the sine of 45. And that would give you what this point is right here. The xy value of that point, and the way they write the answer would be to put it into this format. Actually, they use the hats over the top of them. And if we look at it, what do you know about the x value? It will be negative, and the y value would be positive. So those are the problems you've worked with. What they want to just point out in this lesson is that this angle right there is known as the related angle. So when we talk about the related angles, it's always going to be the positive angle, and is the acute angle between the vector and the x-axis. So we never talk about, even if we talk about negative 30 degrees, we refer to it as positive 30 degrees in our calculations. So the related angles, if we talk about the bow tie effect, your related angles, depending on what quadrant you're in, you think about your bow tie and how you wear your bow tie, and your related angles are always towards the x-axis. What is not a related angle is we do not wear our bow tie this direction, so the angles towards the y-axis are not related angles. So that's not the way you want to draw your triangles whenever you're making reference to finding an angle measure. 135. So the last example we had where we said 135 degrees. If we know this is 135 degrees, we do not want to create our right triangle right here and find out that angle measure. We don't want to come up with that. That's not what they're looking for. Even though that's a perfect example, they're both 45. But that's not what you want to do. We always want to make reference to this bow tie right here. Okay, so that leads us into finding all of these reference angles. If you talk about a first quadrant, we could talk about a 3, 4, 5 angle. And what this is leading us into is if we talk about the first quadrant, here's our reference angle. This would have 3, 4, and 5 for an example. 3, 4, 5 right triangle. Every single side is positive. So when you talk about the sine of your angle measure, or theta, that's going to be equal to 4 over 5, a positive value. If I talk about the cosine of that angle measure, that's going to be equal to 3 over 5, which is also positive. And if I make reference to tangent of your angle, that's going to be equal to opposite over adjacent, or 4/3, which is also positive. So sine, cosine, tangent are all positive in the first quadrant. In the second quadrant, if you were to make your reference angle, what do you notice about the x value? It's actually negative. So if you talk about the sine of that angle, the sine of the angle is the opposite side over the hypotenuse. The cosine of that angle measure is adjacent over hypotenuse, and the tangent is going to be, sorry, I should have put my angle measure there, the opposite over the adjacent. So which values are negative? Cosine and tangent, and which one is positive? Sine. Okay, in this quadrant, if I look at it, I'm going to have my -3, my -4, and 5. So if we talk about the sine of your angle measure, sine is opposite over adjacent. Cosine is adjacent over opposite over hypotenuse. Did I say adjacent there? Or did I say hypotenuse? That's what I thought I said, adjacent. It's opposite over hypotenuse. Sine is adjacent over hypotenuse. And tangent is opposite over adjacent. But if I look at that opposite over adjacent, that's going to be a positive 4/3. So the only one that's positive in the third quadrant is tangent. If I talk about the fourth quadrant reference angle, I know that's not drawn to scale. That's a -4 value because you're dropping down. So the sine of your angle is opposite over hypotenuse. The cosine of your angle is adjacent over hypotenuse. And your tangent is opposite over adjacent. The only one positive in the fourth quadrant is cosine. That will always be true no matter what your angle measure is. So that leads us into something you probably already have on note cards. You probably already have it on your unit circle that we created, right? You still have that unit circle with you. Okay, when we talk about that unit circle, the quadrants in which your trig functions are positive or negative, all of them are positive in the first quadrant. The only one positive in the second quadrant is sine. So this is where they are positive. The only one positive in the third quadrant is tangent, because it's a -x and a -y, which makes it a positive. And the only one positive in the fourth quadrant is cosine. So if you remember, all students take calculus, that'll tell you which values are positive in which quadrants. So that leads us into something like this, where they ask you to evaluate for the cosine of 135 degrees. So I find out where 135 degrees is. Where's that? In the second quadrant. What's the reference angle? 45 degrees. This is just the process I go through. So I think about, okay, I want to figure out what quadrant and what's the reference angle for that. So that's what I ask myself. What quadrant? Because quadrant's going to tell you if it's positive or negative. And then I need the reference angle. So I think to myself, it's going to be 4 times the cosine. What do you know about cosine in the second quadrant? It's negative, so I'm going to put my negative down. And now I have 45 degrees as a reference. What's the cosine of 45 degrees? Radical 2 over 2. So I am multiplying those. You're going to get -4 radical 2 over 2, but you can reduce the 2 and the 4. So your answer is -2 radical 2. So the first thought, figure out what quadrant and the reference angle. From there, Just go ahead and calculate sine, cosine, tangent of your reference angle. The quadrant's going to determine what the sine is. Here's another question over that one. Another example. -2, the cosine of negative 150 degrees. So I have -2 times, right? What's your thought? We got to figure out where is negative 150 degrees. Third quadrant, because I'm going to go backwards 150 degrees. What's your reference angle? 30 degrees, right? Because there's 150. 30 gives you 180. So I asked myself, cosine. All students take calculus. What about cosine? It's negative, so I'm going to put my negative sign down. Now I need the cosine of 30 degrees, which is radical 3 over 2. A negative times a negative is a positive. 2's cancel, and you are left with radical 3. Okay with that? Another example. So I'm going to have 5/3 cosine of 300 degrees. What quadrant is 300 degrees? Fourth quadrant. What's the reference angle? 60. All students take calculus. The question asks you the cosine of 60 degrees. Cosine is positive in the fourth quadrant. I put it down just to make sure I remembered that I dealt with the sign and took care of it, positive or negative. And the cosine of 60 degrees is 1/2. So your answer is 5/6. I like these types of problems. You have 16 and 17 on page 192 that deal with this if you want to look at them real quick. I can just put it up here. 16. 16 is 3, the cosine of 300 degrees. And 17, oh, 17 really doesn't deal with it too much. That's okay, we'll calculate 17, and then we'll look at 18. 17 is the sine of 60 plus radical 3 over 2, the sine of 30. And then we'll look at 18, which says f of x equals -2 cosine of x. And they want you to find f of -300. Do not use a calculator, it says. Want to try these? I'll give you a second. So we look at the first one. What quadrant? 300 degrees. Fourth reference angle is 60. So I'm going to have 3. What about cosine in the fourth quadrant? It's positive. What is the cosine of 60 degrees? 1/2. So your answer is 3/2. The second one, both 60 degrees and 30 degrees are first quadrant angles, and they're positive. What is the sine of 60 degrees? Radical 3 over 2 plus radical 3 over 2 times the sine of 30, which is 1/2. So you get radical 3 over 2 plus radical 3 over 4. I look at it as 1/2 plus 1/4 radical 3. That's okay. Get a common denominator, which makes that 2/4. So if you combine, you get 3 radical 3 over 4. If I look at the bottom one, they want me to find f of -300, which means I'm taking -2, the cosine of -300. I don't know why these are all cosine, but you could deal with it with sine or tangent. But for some odd reason, they're giving us all cosine. As I look at that, what quadrant is -300 degrees in? First quadrant reference angle is 60 degrees, so I want -2. Remember, the negative right here at the angle is not whether that's not what determines if it's positive or negative. Keep that in mind. Times first quadrant, so that's positive. What is the cosine of 60 degrees? 1/2, and if you simplify that, your answer is -1. Are we good with that? All right.